an NBA team can have 15 players on their roster, but only 13 players can be active on the game day, right? So that means if 3 or more players are injured, the team cannot fill the active roster spots, okay? And suppose that the probability of a player get injured is 4%, and the injuries are independent across players. Then what is the probability that exactly 3 players are injured? So let's say X is the number of injured players on your roster. And then it is binomial distribution, right? If like injuries are random. And the parameters N, P are N is 15. In literally the worst possible case is all 15 players on your roster got injured, right? That is the maximum possible. And the probability is given as 4%, 0.04. We are interested in probability that X equals to 3, right? So you have to find first the number of possible combinations. If you have 15 different players and you have to choose 3 out of them, how many different combinations is coming to here, the first part, and then probability of each combination. Probability that that combination get injured, right? So here, the number of combinations can be calculated using this formula. 15 chooses 3, right? And probability is, so injury probability happens 3 times to 3 players, but the other non-injured players imply 96% happened 12 the other times, 12 times, right? So 12 players are not injured with this probability, and 3 players are injured with this probability. So then let's calculate each of them. So 15 chooses 3. To count as combination, we have to use denominator will have 3 times 2 times 1. And numerator will have 3 numbers multiplied. That starts from 15. 14 times 13. So you calculate this, use a calculator. It is 455. There are 455 different combinations you can imagine, right? When 3 players are injured. And this is small numbers like 0.000064, and this is 0.61271. Right, use a calculator. It's not supposed to be calculated by hand. So anyhow, if you multiply these numbers, then I got 0.017842, right? So it is 1.78% approximately.